Hello. Yeah, let me discuss about the programming of 8051 microcontroller. We should know how to write the program in assembly level language, and also should know the how to write the program in high level language. So before writing the program in assembly level language, we should know the instructions. It's addressing mode. So that is the reason here. First, we are going to discuss about the addressing modes of the instructions. Then different types of instructions. Then we'll go for writing a program. So let us see these are the different instructions. First, let us discuss about the addressing modes. Then the different types of an instruction. Addressing mode is nothing but how the data is going to specify the way to address an operand, that is called addressing mode. Operand means it is a data. So to perform any operation, data is required. It can be direct address or it may be indirect, we can, or it may be in a register, or it may be directly specify the data, it may be direct value, we can load numeric value. For example, here move a comma has 6a. Means this direct number, this numeric value will be copied to register A. Here 6a is the operand and it is also called the source. Always right side will be source, left side will be destination. So when this instruction is going to execute, this direct value is going to copy into the register A. So let us see the different addressing modes. There are 5 addressing modes in 8051. Immediate, direct addressing mode, register direct addressing mode, register indirect addressing mode, then indexed addressing mode. Let us see immediate. Immediate means as we discussed, the data is specified in the instruction. So this hash, we have to write hash for immediate number. Whatever is represented here number, this will directly move to register A. So register addressing mode is nothing but register addressing is nothing but the data is inside a register. The content of R4, here source is R4, will move to register A. It is called register addressing mode. Direct addressing mode is nothing but the data is available in the memory. Its address is going to specify in the instruction. Like move a comma 04. 04 is the address of the memory location. Address of the memory location. The content of this memory location will be copied to register A. And register indirect. In indirect, the address will be stored. I mean, data is stored in memory. Its address will be in R0 register. So at the rate R0 is means content of memory location. That address is in R0 will move to accumulator. Now indexed addressing mode is nothing but here the content of accumulator plus content of DPTR will become the address of the memory location. From that location data will move to register A. Here C stands for code, means raw memory. If the data is stored in the raw memory, we can able to get the data into accumulator. These are the different types of instruction, like they are classified all the instruction in different categories depend upon their functions. Moving data, logical operation, arithmetic operation, jump and call instruction. Moving data, here data will move from right to left. So here from memory location to the direct memory location address specified, here in that left side indirect like this. The moving data, here all instructions will become center, moving the data from source to destination. Then we have logical operations, I mean logical and or XOR, and this clear A means content of A becomes 0. Then complement A will become 1's complement of A, 0 become 1, 1 becomes 0. Then rotate, then we have swap. Okay. So that is bit type is called logical. Now arithmetic operations, There is addition, subtraction, multiplication, division we perform. So addition, content of A will be added with content of register and result will be stored in A. So here is specified. Okay, similarly for subtract, then increment, content of A will be added with 1, then result will be stored in that register A. Similarly, increment content of register, any register, increment content of memory location, content of memory location direct or indirect, you can specify. And similarly, decrement, then multiply, the content of A will be multiplied with B and result will be stored in A and B. Similarly, divide A divided by B, then quotient will be stored in A, remainder will be stored in B. Then DA, decimal adjust after addition. If you are adding the number, all will be performed in hexadecimal. To convert it to decimal, so we are going to use DA instruction. So jump and call instruction, A call, L call is calling the subroutine, then return from the subroutine, return from the interrupt. Then jump, A jump, L jump, S jump. These are the number of memory locations far from the jump, that is 11-bit memory far from the current, then we can use A jump. If it is 16-bit anywhere in the 64K, we can use L jump. S jump is just a short jump, that is 127 to 128 memory location. Then jump at that address specified as jump 0. Here the conditional jump, if 0 flag is 1, that is content of A0 means jump 0, the specified level it will go. Jump not 0, if it is not equal to 0. Compare the content of A and this content of memory location. And flags is going to affect, is it A is greater than B? I mean A is greater than content of this memory location or less than or equal to. Corresponding flags will be changes. Depending upon the flags, they are able to judge which number is greater or less or equal between two numbers. And DJ and Z decrement content of register. If it is not 0, then go to the specified level. So these are the different instructions